hot day, eh? I know you. You're a chipmunso, right? Don't be afraid. I'm a friend. A monkey friend told me about you and your fascination with science. You're perspiring, chipmunso. Feel thirsty? Well, I'm a water vending machine. Come over and get your cold drink. Come on, I don't bite. Oops, forgot to tell you. You need to insert a 20-cent coin into my slot here too. I too need to make a living in chipmunso, and I do think that 20 cents is not too much to ask. Press water in chipmunso. Now choose the state that you want. Solid, liquid, or gas. Ooh, eyes. That should cool you down. What's the problem in chipmunso? Oh, okay. Let's get your drink first. Take a cup here and press liquid. You'll get your drink. Come and sit over here. I shall explain. It's really simple. Surprise! Well, life is full of surprises in chipmunso. It's like this in chipmunso. Matter is the physical part of the universe. Matter is anything that has mass and occupies space. Everything around you is made up of matter. The 20-cent coin that you slot in, the water that you drank, and the air that you breathe are all examples of matter. Although they are all examples of matter, they are quite different. The 20-cent coin is solid, water is liquid, and the air is gas. You see, matter exists in 3 states. They are solids, liquids, or gases. Other examples of solids are tables, chairs, cups, etc. Examples of liquids are water and oil. And examples of gases are steam and the oxygen that we breathe. Most of the things that exist in the universe are matter. However, there are some which are not matter. For example, heat and sound are not matter. Heat and sound do not have mass. They do not occupy space. Hence, they are not matter. Matter is made up of tiny particles. The behavior and arrangement of these tiny particles explain the differences between solids, liquids, and gases. But how do these tiny particles in matter behave? Scientific experiments show that the particles in matter possess kinetic energy. They are constantly moving in a random manner. Scientists now explains that the three states of matter, solids, liquids and gases are different because of the differences in movement and arrangement of their particles. This theory is called the particulate theory of matter. It states that matter is made up of particles which are constantly moving in a random manner. As the particles move, they possess kinetic energy. The particles in solids are arranged closely and packed in a fixed pattern. There is very little space between the particles. Solids have definite volume, definite shape, and are not compressible. Particles in liquids are arranged closely but not in a regular pattern. There is more space between the particles. Liquids have definite volume. Liquids take the shape of their container, and liquids are difficult to compress. Particles in gases are far apart. They are not arranged in a fixed pattern. There is a lot of space between the particles. Gases take on the volume of their containers. Gases are easy to compress because the particles are far apart. Want more water? $0.20, please. Thank you. While you enjoy your drink, let me explain about diffusion. Diffusion is the process by which particles of matter fill a space because of random movement. The movement of particles is always from a region of higher concentration to a region of lower concentration. Here is a test tube containing gel. A crystal copper to sulfate is placed in the gel. The gel is placed upside down and left for a while. Now we can see the blue color of copper to sulfate spreads slowly into the gel. The rate of diffusion is very slow. After a few days, the copper to sulfate crystal disappears and the whole gel turns blue. This phenomenon proves that the particles in solids are arranged very closely together and the spaces between solid particles are small. Next, we shall observe the space between the particles in liquids. Drop concentrated copper to sulfate solution into a test tube containing water using a thistle funnel. The blue color of copper to sulfate slowly spreads and turns the water blue. You see, unlike solids, there are spaces between liquids. Since the spaces between the particles in liquids are larger, the diffusion of the copper to sulfate in water is faster. Do you follow, Encik Mansur? Encik Mansur? Now, let's test on gas. In this gas jar, I have trapped bromine gas. I call this gas jar A. Notice that I have gas jar A covered. Be careful when you handle bromine gas. It is very poisonous. Do not inhale the gas. This is gas jar B. Gas jar B is filled with ordinary air. Okay, now place gas jar B onto gas jar A. Then remove the cover from gas jar A. Observe what happens. Yes, the bromine gas spreads quickly into gas jar B. Now both the gas jars have turned reddish brown. The diffusion of bromine gas particles into ordinary air takes place very quickly. This is because the gas particles in air are very far apart. There are large spaces between the particles. Now let's look at the diffusion of the three states of matter again. In solids, the rate of diffusion is very slow. It took a few days for the copper to sulfate crystal to disappear and turns the whole gel blue. The spaces between particles in solids are small and closely packed together. In liquids, the rate of diffusion is faster. It did not take long for the concentrated copper to sulfate solution to diffuse in water. This is because the spaces between the particles in liquids are big. In gases, the rate of diffusion is the fastest. The bromine gas spreads quickly from gas jar A into gas jar B. In seconds, both the gas jars have turned reddish brown. The spaces between particles in gases are very far apart. Thus, diffusion takes place quickly. I feel that we have learned quite a lot today, Encik Mansur. What? Not yet? Encik Mansur, not just yet. You haven't seen the table yet. All right, here goes. There are 3 rows in the table. We start with the arrangements and distances between particles. In solids, the particles are arranged very close to one another in an orderly manner. There is very little space between the particles. In liquids, the particles are far from one another. They are not arranged in an orderly manner. There is more space between the particles. In gases, the particles are farther from one another. They are also not arranged in an orderly manner, and there's a lot of space between the particles. Now, let's go to the next row. Attractive forces between particles. In solids, the forces of attraction between particles are very strong. In liquids, the forces of attraction between particles are not so strong. In gases, the forces of attraction between particles are almost negligible. Next, movement of particles. In solids, the forces of attraction between particles are very strong. This force holds them together tightly so they vibrate in a fixed position. In liquids, the forces of attraction between particles are quite moderate. This allows them to move freely, sliding and passing one another. In gases, the particles are very far apart. They possess large amount of energy to move about in all directions and at high speed, colliding into one another occasionally. Yes, it's getting very warm. Come and get your drink, Chipmunk. You see, matter exists in three states. They are solids, liquids, or gases. Other examples of solids are tables, chairs, cups, etc. Examples of liquids are water and oil. And examples of gases are steam and the oxygen that we breathe. Matter is made up of tiny particles. The behavior and arrangement of these tiny particles explain the differences between solids, liquids, and gases. The particles in solids are arranged closely and packed in a fixed pattern. There is very little space between the particles. Solids have definite volume, definite shape, and are not compressible. Particles in liquids are arranged closely but not in a regular pattern. There is more space between the particles. Liquids have definite volume. Liquids take the shape of their container, and liquids are difficult to compress. Particles in gases are far apart. They are not arranged in a fixed pattern. There is a lot of space between the particles. Gases take on the volume of their containers. Gases are easy to compress because the particles are far apart.
Matter is a physical part of the universe. Matter exists in three states: solids, liquids, or gases. In and space in between. No definite volume, no definite shape, but still can be compressed.
I'm glad you understand my explanation on the 3 states of matter. I guess you want to make a move now, right, Encik Manso? Bye, Encik Manso. It has been nice talking to you. Hope to see you soon. Bye.
Excuse me, sir.
Yes?
Did you see that vending machine?
Yes?
Did you hear that vending machine talking to me?
No. I did not see the vending machine talking to you. But I see you talking to the vending machine. It's a hot day, SAINS. We all get hallucinations once in a while. Don't worry.